நீங்க டாபிக் சொல்லிட்டு ஸ்டார்ட் பண்ணலாம் சார். ஒரு ப்ரிலீடு கொடுத்துருங்க சார். இது எது சம்பந்தப்பட்டது, எந்த சாப்டர்ல வருது, இதுக்கு என்னென்ன இது அப்படின்னு சொல்லிட்டு ஒரு இன்ஃபர்மேஷன் கொடுத்துட்டு நீங்க ஏன்னா ரெகுலரா அந்த கிளாஸஸ்ல போயிட்டு இருக்கட்டும் சார். நான் வந்து பிரிட்ஜிங் கிளாஸஸ் மட்டும். ஸோ நீங்க வந்து ரெகுலர் கிளாஸஸ்ல அதை சொல்ற மாதிரி பார்த்துக்கலாம் சார்.
ஓகே 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 ஓகே
தேங்க்யூ
sir. Good evening to all.
Good evening, sir.
Yes, sir. This topic is one important topic, sir. We saw financial management law in my last class. Financial management will get us nearly minimum of 10 marks in the examination. These are all coming in the subject one, sir. Subject one, general energy scenario. And again, this material and energy balance chapter will also get us a minimum of 10 marks. Both are problem oriented and we have to practice. Otherwise, will not be able to get the marks in, will not be able to attend the questions in time. Time is an important factor, sir. That's why we have to practice. For today also, if we have some calculator or anything, it will be easier for us. Shall we start, sir? Sir, kindly interact in between. Am I audible?
Yes, sir. Perfect, sir.
Okay,
Yes, sir.
sir.
Yes, sir.
Thank you. Thank you.
Yes, sir. Yes, sir. Audible, sir.
Thank you. Thank you. Thank you. Sir, the basis for material and energy balance is nothing but our basic fact, that is two bases: law of conservation of mass. Matter can neither be created nor destroyed. And again, law of conservation of energy. Energy can neither be created nor destroyed. On these two principles only, the total subject, total chapter is built. Material and energy balance. Sorry, this chapter, at first seemingly, it may look so easier, but the problems are tricky actually. Unlike our financial management, the problems in this chapter is somewhat tricky. So we have to think and solve the problem. For the purpose of this material and energy balance, they are asked in 3 marks question in one year now. I think so, sir. And frequently they are asking in 1 mark. Purpose is to assess the input, assess the conversion efficiency, output and losses. That's all. The elaboration is quantify all material, energy, waste streams in a project, process or a system. This is a powerful tool for establishing basis for improvement and potential savings. What you will learn after completing this chapter: need for material and energy balance, understanding Sankey diagram. The Sankey diagram is frequently they are asking for 5 marks. How to construct a process flow diagram, energy system analysis, how to carry out material and energy balance. It's on typical diagrams. See, raw materials, chemicals, water, air, energy, power. And you can see in the left side, in blue letters, recycle. Recycle means from the output, one line is taken back, it is fed into the input stream. So the recycle is also one input in the stream. Reusable waste in other operations. Products, byproducts, wastewater, liquid waste. All these things we will be seeing in the exam. So just look at it and have an idea. We will work out in an example. The formula mass. The raw materials input is equal to the products plus waste plus stored materials. total raw materials, total products. Sigma is given for the total waste products, total stock products. Same thing. The same thing is applicable for energy. Energy is equal to energy out plus energy stored. So based on the process, there are two types: steady state process, where the variables do not change with time; unsteady process, where the process variables change with time. Most of the problems we'll be dealing with that steady state process only, sir. So we need not bother about the unsteady process. Continuous process. Continuous process means it will be given in tons per hour or something, and it will be running for 24 hours a day. So we'll be taking for a particular time or particular feed rate, you'll be solving the problems. Batch process means it will run for 4 hours and stops. And again, we'll be calculating using for that 4 hours only. These are all just look and observe, so that's all. You will understand everything while working out the problems. Material balance. Overall material balance involves input and output process. Section-wise material balance. Equipment is material balance. Because in a factory, a particular process will be so much of importance and will be involving much of money or valuable raw material. So we will not be doing all material balance for every process in a factory. That's why the section-wise material balance, equipment-wise material balance are categorized. Procedure we will not be seeing, sir. That is available in the book. We'll go through the problems directly so that we will not waste time today. I just want to complete this chapter in, today itself. That's why I'm going skipping this example. So the letters are all the letters are visible, sir. Can you read? I just took a screenshot. Is it visible?
Yes, sir. Yes, sir. Visible.
Okay. Yes, sir. Solution which contains 10% solids is mixed with 25% solid solution. That means they have got one solution. In that solution, the liquid portion is 90% and the solid portion is 10%. And they are mixing it with another solution that is having 25% of solid part. And the output is single output. The 10% solution rate they are given. They are asking for other two rates. Is it okay, sir? Understandable? We have to draw a block diagram. Then only it will be easier for us to solve the problem. They are given solution A. That is the rate of flow they are given. That is 5 kg per second. Did you see it? See. If the 10% solution enters at 5 kg per second, what are the other rates? Okay. So they are given solution A, 5 kg per second, and it contains 10% of solids. What does it mean, the 10% of solids? Suppose we have in seawater portion 10% solids means if you dry it, you will get only 10% of the total weight as solid. The 90% will evaporate. That is the meaning. Solution B contains the rate of solution B, we do not know. We have to find it. And they are given the percentage of solids, that is 25%. Solution C, that is the rate of solution C, that is the output. That's also we have to find. The solids in that solution is 25%. all these things we need to understand and draw it in a diagram. Otherwise, you will not be able to do the problem. This is the basic requirement, sir. We have to do this. Steps, equations. Rate of input 1 plus rate of input is equal to rate of output. This is okay for us, sir. For example, 10 liters per second, one stream is going in, and 15 liters per second, another stream is going. One output is we are getting out. We just have to add both the rates. Simple, nothing complicated. But we have to add the rate only. That means we saw 5 liters per second or something. Sorry, 5 kilograms per second. 5 kilograms per second plus X is equal to Y. X is the second input. Y is the output. 5 plus X is equal to Y. We keep it as equation 1. From the above equation, equating the quantity of solids. Here comes the material balancer. Whatever we are letting in will come out. There is no storage. So whatever solids going in will come out. 10% of 5 kilograms per second. And plus 23% of the extreme, that is input 2, will be equal to 20% of Y. Is it okay, sir? Is there any doubt in this line? 10% of Y plus 20% of X. 10% of 5 means that first input contains 500 grams. 500 grams of solids is going in. Is it okay, sir? Okay, let's move on. That is 0.5 kg plus 0.25x is equal to 0.2y. Just an equation, that's all. Two unknowns, we have got 2 equations. We can solve it easily. Y is equal to 15 and then X is equal to 10. Is it okay now? Can you do this, sir, easily? Sir, please stop me in between. If there is any difficulty.
Okay, sir.
Yes, sir.
Okay. Right.
Okay, sir. Okay.
Okay, sir. Without this basis, we'll be getting confused, sir. That's why I'm asking repeatedly. Right, we can add. Same time, the material also we can equate. Input is equal to output. Second problem. We have a solution which is 80% oil, 15% usable byproducts, and 5% impurities. Let us say refinery. One is one output is 92% oil and 6% usable byproducts. The other output is 60% oil and flows at the rate of 1000 liters per hour. In the first solution, they are given oil percentage, byproducts percentage, and impurities percentage. Whereas on the output side, in one output, they are given the oil percentage and byproduct percentage, but they are not given the impurities percentage. In the second input, they are given the oil percentage and they are not given the impurities percentage as well as the byproducts percentage. but they are given the rate of flow for the second output. In most of the problems, you'll be seeing one information, assume no accumulation. All these are percentage by volume only, not by weight. Refinery input is 80%, byproduct 50%, 15%, impurity is 5%. The output 2 is oil 60%, 1000 liters per hour. In the only one output, they have given the rate. They have not given it for input as well as for output one. This diagram we have to draw. So it will be easier for us to solve the problem easily. What we can compare, sir? Just see the diagram. Just observe. I'm deliberately delaying to rush on to the next slide. Just observe, please. We can get one data from output to 1000 liters per hour. 1000 liters per hour, in that 60% is oil. So we can get oil in the output, that is 600 liters. One data we can readily get.
Yes, sir.
Oh, right, okay, right, thank you. This is the question. Flow rate of input, composition of 1000 liter, all these things will go. Refinery, X liters per hour. Steps first. X plus Y is equal to, sorry, X is equal to Y plus 1000. X is the rate of input, that is equal to Y. That means output 1 plus output 2 is 1000. From the above equation, equating the quantity of oil, that is 80% of X is equal to 6% of oil plus 60% of 1000 liters. Okay, sir. Just compare, we are comparing the oil only. 80% of input rate is equal to 6% of output Y plus 60% of 1000 liters. That is 0.8X plus 0.92Y plus 600. 0.8X is equal to 0.92Y plus 600. From equation 1, we can substitute this in the second equation. And solving this, two unknowns, two equations we have got, so we can solve it easily. We got Y is equal to 1667 and X is equal to 2667. We can go back and look into the picture. See, sir. This one is 2667. This one 1667. Is 1667 plus 1000. It is 2667. We have got the answer for rate. Rate of input is equal to output, rate of output 1 plus rate of output 2. Again, byproducts of output. 6% of 1667 liters. That is equal to 100 liters. Byproducts of input is equal to 15% of 2667. That is equal to 400 liters. So with this, we can derive the product byproducts in the output too, because whatever we have given in is 400 liters of byproducts. 400 minus 100 will give us 300 liters. So we have found byproducts byproducts also. In case of impurities in the input is equal to 5% of 2667, that is 133.33. This will be shared in output 1 and output 2. Impurities in output 1 is equal to can we go back to that diagram, sir, so that it will be easier for us to understand. Impurities 5% we have found, and we can see oil is 92%, byproduct is 6% in the output 1, so that 92 plus 6, what is the balance, sir? That is just 2%. 2% is attributed to impurities. Here 5%, we have to find it from the input rate. 5% multiplied by the weight, that will be shared by Y and output 2. Output 1 and output 2. So this is from this 92 plus 6, 100 minus 92 plus 6, that is 2% is the impurities in output 1. I just came back to see that diagram. Okay, sir. Impurities in input is equal to 133. 2% of 1667 is equal to 33.33 liters. So 133 minus 33.33 will give us 100 liters. In output 2, the impurities in output 2 will be 1000 liters. And they asked one question: impurities in output 2 as percentage of input. As percentage of input means this 100 divided by input stream, that is 133.33. That will come to 73%. Okay, sir. Any problem?
Okay, sir.
Okay. Can we go to the next problem, sir? The skim milk. Skimming means removal of fat, sir. Skimmed milk means it is fat-free milk. So, in this problem, skim milk is prepared by removal of some of the fat from whole milk. The skim milk is found to contain 90.5% water, 3.5% protein, 5.1% carbohydrate, 0.1% fat, and 0.8% ash. Ash is nothing but it is not edible. That's all. Like ash in our coal, this 0.8% ash is not a edible quantity. Others are edible. If we consume it, that 0.8% will not be utilized by our body and it will go as waste. The original milk contains 4.5% fat. Calculate the composition assuming that fat only was removed to make the skim milk and there are no losses in processing. Because this question has been simplified, sir. Otherwise, in the processing, definitely will be lose some water. But they're telling there is no loss in processing. So the problem is easier for us to tackle. Once again, we have to draw the diagram. The whole milk, which contains 4.5% fat. The skim milk contains 90.5% water, 3.5% protein, 5.1% carbohydrate, 0.1% fat, 0.8% ash. Steps: equating the quantity of liquids. that 90% of 5 plus a 75% of x is equal to 80% of y. The diagram was incomplete. Sorry. 90% of 5 is equal to 4.5%. Is equal to 78% of x and 0.8. We are just making one equation. Sorry, some error has occurred. So we'll go to the next problem, sir. Similar problem. In a continuous centrifuging of milk, 35,000 kilogram of whole milk contains 4% fat is separated in a 6-hour period. So we can see this process is batch process. It is not a continuous process. Whereas in a thermal power plant, it will be running 24 hours a day. That is a continuous process. This one is batch process. In a 6 hours period, the milk is processed. 35,000 kilogram of whole milk. Whole milk means unprocessed. We'll draw the diagram for whole milk, 4% fat. The rate is 5833 kilogram per hour. Why 5833 kilogram per hour, sir? You have converted. 35,000 is the kilogram of whole milk. That is for 6 hours batch process. We are dividing it into 6 and we are getting as 5833 kilogram per hour. Skim milk output and cream output. There are two outputs. One is skim milk. Skim milk means fat-free milk. Fat-free means it is not totally fat-free. Fat is very much reduced. That is 0.45% of fat it contains. The next one is cream. Cream contains 40% of fat. Steps. X is equal to y plus z. That is 5833 is equal to y plus z. Equation 1. Quantity of fat in the whole milk input 4%. So we are getting one input, that is 4%. This is the total fat available in the whole milk that will be divided into the both streams. This will not change. 233.33 kilogram of fat will remain same when adding the output 1 and output 2 for fat. We will get 233.33. That's the very basis of material balance. 233.33 is equal to 0.0045y plus 0.45z. This is the rate they are given in the question. Once again, we are doing the two unknowns, two equation method. We'll be getting z is equal to 464.6 and we are getting y. I is coming here. I made a mistake somewhere else. Yes, sir. We'll see another problem. Sir, so far any doubts, sir, please ask me. Is it okay?
No doubts, please.
We can proceed, sir.
Okay, sir.
Yes. Okay, sir. Thank you. Solution of common salt in water is prepared by adding 20 kilogram of salt in 100 kilogram of water. Sir, we have to do all these problems, sir. These are all very easy, but it is very much required for attending a problem in the examination. Actually, I superficially studied during 2011 for in this chapter, and actually I struggled a lot in attending the problems came from this particular chapter. So kindly pay attention to the problems. Definitely will get 10 marks in this chapter, sir.
Sure.
Common salt in water, 20 kg of salt in 100 kilogram of water. To make it liquid density, 1323 kilogram per meter cube. Calculate the concentration of salt in this solution as weight fraction, weight per volume fraction, mole fraction, molar concentration. So this problem is an important problem, sir, because so far we have seen weight, volume, percent. Now we are seeing mole and all those things. Before going into this problem, I just want you to interact, sir. Can we interact, please, freely? Don't make a delay, sir, please. We're running out of time. Can anyone tell me what's a mole? Mole, M-O-L-E, mole. No, sir. You want me to explain what's a mole?
Yes, sir. Please, sir.
Yes, sir. Mole is nothing but a number. Just like 12 means dozen, cross means 144, pair means 2. Just like that, mole means it is 6.022 into 10 power 23 items. That's all. 12 items, we call it as a dozen. 144 items, we call it as a gross. 6.022 into 10 power 23 items, we call it as a mole. Is it okay, sir? Kindly keep this in mind.
So once again repeat, sir, please.
Sir, it is just a quantity. If we say 12, 1 dozen, what does it mean? It means 12 units, 12 numbers, that's all.
Oh, yeah, told me.
If you say 1 mole of oxygen, 1 mole of O2, oxygen molecules, there will be O2 molecules 6.022 into 10 power 23 O2 molecules. It can be a molecule or it can be an atom. We don't bother about it. We are bothering about the quantity only. It can either be a molecule or an atom. 1 mole means 6.022 into 10 power 23.
23.
It's nothing but we call it as Avogadro number. Okay, sir.
Okay, thanks.
Sir, this is very much required for our entire subject, sir. Mole. We kindly don't forget.
Okay, thank you.
Volume of CO2 is 3 meter cube. Volume of water 1 meter cube. Oh. Jumbled, I think. 1 second, sir. Just a minute, sir, please. Sir, I have opened the PDF file. Can you read the letters? Is it visible, sir?
Okay, sir.
Solution of common salt in water is prepared by adding 20 kilogram of salt to 100 kg of water to make a liquid of density 1323 kilogram per meter cube. Asked for weight fraction, weight per volume fraction, mole fraction, and molar concentration. In the first step, weight fraction means simple, sir. That is 20 grams of water is salt is added. 20 divided by not by 100, sir. Just remember 100 plus 20. The total solution will contain 100 kilogram of water plus 20 kilogram of salt. That is the solution, weight of solution. That is the total weight of solution. So the salt percentage is 20 divided by 120, not 100. 20 by 120 will give us 0.167. Weight bar weight fraction is 16.7%. Simple. Then weight bar volume. 1323 kilogram per meter cube means 1 meter cube of solution. The density, what do they mean? 1323 kilogram per meter cube means that solution, that is 1000 liters of solution, weighs 1323 kilogram. That is 1323 kilogram salt solution contains weight per volume, sir. Just see the steps, sir.
Mass by volume.
Yes. Density is mass by volume. Actually, it's prepared step by step by somewhere I missed it. Okay. The denominator is 100 plus 20. That is total weight. In the numerator, 20 kg into 1323 kilogram per meter cube. You get 220.5 kilogram of salt per meter cube. Weight per volume fraction comes out to 22.1. This you can easily understand by going again, sir. No problem. But you'll come to the important part of this problem. second B, weight per volume, you can do it on your own, sir. No problem. But moles, sir. In some for few elements, we need to keep in mind the molar mass, molar weight. I mean, for oxygen, oxygen is available as O2 in the atmosphere. Whenever we say oxygen means it is O2 molecules only. The weight of 1 mole of oxygen is 32 kilogram. All these things they have found already. We don't bother about that. We have ready-made data. That means 6.022 into 10 power 23 molecules of oxygen weighs 32 kilograms. Is there any doubt, sir? For oxygen, this is 32. One oxygen atom contains, atom weighs 16 kilogram. Whereas for O2, it is 32. And moles of water. Sir, what is that 18, sir? $18 is nothing but, can you see that 18 in part C, moles of water is equal to 18, 100 by 18. What is that 18? In H2O, the
Hydrogen is 2, sir.
yes, hydrogen is 2, that is H2, hydrogen 1.
Plus oxygen is 16.
Yes, you're right, very good. H2 means 1 plus 1, 2, oxygen 16, so total molecular weight of H2O, water is 18. Yes, sir. 1 mole of water, H2O molecules weigh 18 kilograms. What is that? Weight per volume fraction. We have found 3 mole fraction. Mole fraction means this is 18 is the kilogram per mole. In the numerator, it is kilogram. In the denominator, kilogram per mole. So we will get 5.56 moles. Okay, sir? Is it okay?
Yeah, okay, sir.
Moles of salt, similarly. For salt, what is that salt?
20 kilogram.
58.5. 58.5 is
How 58.5, sir? How 58.5, sir?
Yes, sir. That is NaCl, sir. What we have found for H2O 18, this is for NaCl, sodium chloride, this is 58.5. Okay, sir. You just be on the line, sir. 1 second, please. I missed those slides. That's why I'm struggling. Just a second. Sorry for the delay. Uh, for chlorine, it is 35.5. Okay. For sodium, it is 22.5. So adding both, we get 58.5, sir. 22 point something plus 35.5, we get 58.5. We can keep it in mind as this one, sorry.
Yes, sir, you can continue, sir.
Sir, okay.
Sodium plus chloride.
Yes. Is the screen visible, sir? Okay. Still.
Yes, visible,
Okay.
sir.
Okay. Right. Thank you. 58.5 is for sodium chloride. That's all. Na and Cl moles. Once again, 20 kilogram divided by 58.5 mole per kilogram. Sorry, kilogram per mole. Kilogram divided by kilogram per mole will give us 0.34 moles. The moles of salt, 0.34 moles are there in that solution. Is it okay? Uh, 5.56 moles of water is there in the solution. Same time, 0.34 moles of salt are there in the same solution. Mole fraction of salt is equal to 0.34 divided by 5.56 plus 0.34, that is 0.058. This is the mole fraction. That's all. And once again, molar concentration is, we have already found one, 220.5 kilogram. 1 meter cube of solution contains 220.5 kilogram. 220.5 divided by 58.5, we get 3.77 moles in 1 meter cube. This is molar concentration. Simple, sir. That's all. I will share this PDF in our WhatsApp group, sir. No problem. You can go through it once again. Can you move further, sir? Because we are running short of time. Can you move, sir? Okay. Molar fraction and all.
Yes, sir.
The previous
It
problem,
will be little confusing, sir. Previous
problems are also in the PDF format, sir, with you, like this.
No, sir. Everything is in the PDF. But for clear understanding only, I brought those things into the PPT.
Better you share.
Yes, sir. I will share both, sir.
Okay, thank
you. I missed some slides somewhere. That's the problem. That's why we are facing such a problem, sir. Nothing else. I think we can skip few more problems and we'll go for energy balance. These are all the problems they are asked in example. Oh, we are not able to see this. No? Yes. Okay. Sorry. So is the screen visible now?
Yes, sir.
Sorry.
Sir, no audio, sir.
One second. Some technical problem. I am unable to share it. Is it visible now? Is the screen visible, sir?
Yes, sir.
Ah,
Yes,
one
sir.
second. In the week, end of the week, if you find time, we can solve some more problems, sir. Otherwise, we'll do it in our homework. Otherwise, we cannot complete the subject. Energy balance. Energy balance is the screen visible? Your furnace shell. Furnace shell has to be cooled from 90 degree to 55 degree. Is the screen visible, sir?
Yes, sir.
Or you are seeing some other screen? Okay. The mass of the furnace shell is 2 tons. The specific heat of furnace shell is 0.2 kilocalories per kilogram degree centigrade. Water available at 28 degrees centigrade. The maximum allowed increase in water temperature is 5 degree. Calculate the quantity of water required to cool the furnace, neglect heat loss. This is somewhat lengthy problem, sir. Kindly once again see the problem. Furnace shell has to be cooled from 90 degrees centigrade. It is very hot after the process is over. It has to be brought down to 55 degrees centigrade. The mass of the furnace shell is 2 tons. That is, you remember that formula: mass into specific heat into temperature difference. MCP dt is MCP into delta T. We might have used in our earlier days. That is, mass is 2 tons. The specific heat, they are given 0.2 kilocalories per kilogram. Water is available at 28 degrees centigrade. That is the input water. Maximum allowed temperature is 28. The output temperature shall be 33 only. Calculate the quantity of water required to cool the furnace. We'll go step by step. Energy in stream 1. Stream 1 means that energy in the shell, heat in the furnace shell, which has to be removed. That is equal to furnace mass into specific heat of the furnace into temperature difference. 2 tons, 0.2 kilocalories per kilogram is the specific heat they are given for furnace shell. That material that we don't know what is that material, maybe iron or something else, that is 0.2 kilocalories per kilogram degree centigrade. Temperature has to be brought down from 90 to 55 degree, that is delta T. MCP delta T. What do you get? 14,000 kilojoules. The same heat has to be removed by the cooling water. Is equal to mass of water into specific heat of water into temperature rise in water. Mass into the specific heat of water is 1 kilocalorie per kilogram degree centigrade. Is equal to the heat to be removed from the furnace shell. 14,000 kilocalorie, we have found it already. Therefore, mass is equal to that 14,000 divided by 1 into 5. 1 is that specific heat of water. That step, sir. This step. Can you see this pointer? Sir, can you see the pointer I'm using?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So 2,800. Okay, 2,800 kilocalories. Sorry, kilograms. Simple. Sir, any problem in this? Any shortcoming in this problem? You can move. Thank you. Energy balance, mass balance, both are very much important in this chapter. Dry air heat balance. Sir, are we running out of time? I think I'm crossing my limit. Okay, sir. I think without doing this problem, we'll conclude here. I think we have to work it out in the home, sir. Otherwise, you'll do it in another day. Otherwise, we'll be going beyond the time. Okay, sir. Is there any doubts? Please ask me. I'll share the PPT as well as the PDF.
PDF format is enough, sir.
Oh, PPT is not required. Okay, okay then. In the PPT, I have collected some questions from the previous question paper, sir. That will not be available in that PDF.
Okay.
Sorry for the errors in the PPT. Very sorry. Okay, sir. Please raise your questions or we will conclude. Please do read that mole and molar mass, all these things, sir. Mostly we'll get sodium chloride, H2O, that's all. We'll not be getting something else. For sodium chloride, this is 58.5. For H2O, it is 80. One more thing, CO2 will be dealing, sir. For CO2, it is carbon, it is 12 kg per mole carbon, and the O2 is 32, C plus O2. CO2 weighs 44 kilogram per mole of CO2 molecules. All these things we have to keep in mind. Otherwise, they may not give the question papers data. Okay, Bala. Dr. Bala, please. Sir, what about this today's session, sir? Was it useful?
Sir, really useful, sir. The new concept, new things we learned today.
Okay, sir. Kindly practice tomorrow itself, sir, please. Otherwise, you'll be forgetting everything. You cannot forget this. Sir, please keep in mind, we don't have any choices in the question paper. All the questions we have to answer. For 150 marks, we have to answer the questions. And we will get, for out of 150, we will get minimum 10 marks in this chapter. Energy and mass, energy balance and mass balance. Problem part alone, we will get 10 marks. And in short questions, they may ask for 5 more marks also. 15 or 20 marks we will be getting in the paper 1 from this chapter. So don't forget this paper chapter. Please do lot of problems in your home. Otherwise, you will not get much time in the examination. Time is the main requirement in the examination that we have to practice. Otherwise, will not be getting the required marks to pass. That's my suggestion. I'm telling from my own experience. Okay, sir. Can we conclude?
Yes, sir.
Sir, if heat losses are given, then we have to go by the direct method of calculation.
Sorry, heat losses.
Here in this problem, heat losses are given as negligible.
Sorry, which one? This
The
one.
previous problem, sir, energy balance problem.
Yes.
Heat losses are given as negligible.
Yes. Yes. Yes.
If
You're
it
right.
is given,
We have to calculate.
okay, then it will be a bit lengthier problem. Sir.
For example, in the ash and reject, we'll be losing some yield. They will give it in some quantities, and we have to multiply it with the mass removed from the bottom ash.
Okay, sir, fine. Thank you.
That will be the energy lost in the reject. And also in flue gas also the energy will be lost. That we have to multiply it with the temperature and the mass. So for energy balance in the thermal power plant, we'll be dealing with all those things. Flue gas, bottom ash bottom ash. Yes, that's all.
Thank you, sir.
Yes. Okay. Sir, can we see this problem, same problem tomorrow or day after tomorrow? Can we see some more problems? I'll correct the PPT and present once again. Is it required? And Saturday evening, can we see this chapter once again?
Better, sir. Better, sir.
Yes, sir. Better, sir.
Yes, because this is a vague at first time, mole and everything, molar fraction and everything will be little bit confusing because we are seeing it after a long period. It will be a little bit confusing. I'll make a perfect PPT and present it on Saturday. And one more thing, for one question, few questions from subject 4. That is the open book examination, the more challenge examination. I'll get few more questions from the subject also for financial management subject that we studied in the last week. We'll cover both on Saturday. Is it okay for us?
Yes, sir. Okay, sir.
All right, so thank you.
Thank you.
Thank you, sir. Good night.
Okay, sir. Thank you, sir. Good night.
Good night, sir. Good night.